Hello viewers, so today we'll take an important topic, that is derivative of one function with respect to another function. Clear? Let fx and gx be any two functions. Clear? And these two functions are differentiable. Clear? These two functions are differentiable in their domain. Suppose we have to find the derivative of f with respect to g. That is, we have to find dfx over dgx. Clear? So the derivative of one function and the function is say f with respect to another function. The another function is g. So viewers, here we have to find the derivative of f with respect to g. So what we will do, we will first find the derivative of f with respect to x, because f and g are functions of x, and then we find the derivative of g with respect to x, and we'll divide these two results and we get the derivative of f with respect to g. Clear? Now let us take a simple example. We have to differentiate e raised to 2x with respect to log 2x. So what we will do, we will assume fx as e raised to 2x and gx as log of 2x. Clear? Now find the derivative of f with respect to x, which is the derivative of e raised to 2x is e raised to 2x, and by chain rule we get the derivative of 2x as 2. Similarly, the derivative of g with respect to x is 1 over 2x, because the derivative of log x is 1 over x. So 1 over 2x, and then we have 2. Clear? So this is 2 e raised to 2x, and this is 2 get cancelled, and we have 1 by x. Clear? So therefore df over dg is equal to df over dx divided by dg over dx. Clear? So df over dx is equal to 2 e raised to 2x divided by 1 over x. So this becomes 2x e raised to 2x. So this is the required derivative of the exponential function e raised to 2x with respect to the logarithmic function log 2x. Clear? Let us take one more example. Here we have to differentiate e raised to sin x with respect to cos x. So what we will do, we will assume let fx is equal to e raised to sin x and gx is equal to cos of x. Now find the derivative of f with respect to x. So this is e raised to sin x, and the derivative of sin x is cos x. Clear? Similarly, the derivative of g with respect to x is minus of sin x, because the derivative of cos x is minus sin x. Now df over dg is equal to df by dx over dg by dx. So df over dx is this. So we have e raised to sin x multiplied cos x divided by, we get minus of sin x. Now which can be simplified as minus e raised to sin x multiplied cos x over sin x is cot x. Clear? So this is the required derivative. Now let us take one more example. Here we have to differentiate sine root x with respect to tan x. So what we will do, we will assume this function as fx and this function as gx. Clear? Then we'll find df over dx. So the derivative of sine root x, the derivative of sine x is cos root x, and the derivative of root x or the square root of x is 1 over 2 square root of x. Clear? Similarly, dg by dx, that is the derivative of g with respect to x, is the derivative of tan x is secant square x. So therefore the derivative of f with respect to g is the derivative of f over f with respect to x divided by dg by dx. So what is df over dx? It is cos root x over 2 root x divided by we have secant square x. Clear? So this can be written as cos root x multiplied, because 1 upon secant square x is equal to cos square x. So we have, this is cos square x multiplied 1 over 2 root x. So this is the required derivative. Clear? Let us consider one more example. Here we have to differentiate sine inverse x square with respect to tan inverse of x. So what we will do, we will assume it to be fx and this function is to be gx. Now we will find df by dx. So what we will get, the derivative of sine inverse x square, the derivative of sine inverse x square is 1 over square root of 1 minus x square. So x square means we'll substitute x square for x. So x square and then by chain rule we'll have the derivative of x square as 2x. So this is 2x over 1 minus x raised to power 4. Similarly, dg by dx, we have to find the derivative of tan inverse of x, which is equal to 1 over 1 plus x square, because this is the simple result. Now the derivative of f with respect to g is df over dx divided by dg over dx. So df over dx is this expression, 2x over 1 minus x raised to power 4 divided by 1 over 1 plus x square. Clear? Now we can write it as 2x over square root of 1 minus x raised to power 4 multiplied 1 plus x square. Clear? Now we can also simplify it further, that is 2x, and this expression can be written as square root of because 1 minus x raised to 4 can be written as 1 square. So this can be written as 1 minus x square 1 plus x square, a square minus b square. So we can write it as 1 plus x square multiplied 1 plus x square. Here we have power 1 and here we have power half. So this can be written as 2x square root of 1 plus x square over square root of 1 minus x square, or this can be written as square root of 1 plus x square over 1 minus x square. Clear? Here what we have